Welcome to this short demo. In this demo, we will use two deployment methods to quickly deploy and test LiteLLM with our Poolside models. We will then also test inference using the LiteLLM endpoint. Okay. So what is LiteLLM? So LiteLLM is an OpenAI-compatible LLM gateway. It sits in front of your vLLM model and exposes a single OpenAPI endpoint, and clients connect to it by sending standard OpenAPI requests. LiteLLM then takes those requests and route them by the model name field in the request body. That's how it sends it to the correct upstream service. We will be using the instructions from the LiteLLM docs. I want to talk about the prep that I have done so far for this demo. I have deployed Poolside model in one of my OpenShift lab environments. I have intentionally enabled an external OpenShift route on my vLLM endpoint for this demo. It is because so that I can connect to it directly from outside the OpenShift cluster. I have a valid kubeconfig so that I can use to connect to my lab environment. I also have Helm and kubectl binaries installed on my machine. For the first demo, I installed Docker, and I also have our harness pool installed on my laptop. I have a DNS entry for my inference endpoint. This is for the first part of the demo. I also have a DNS entry for my LiteLLM endpoint for the second part of the demo. In this demo, I'm not using any TLS, so everything goes over HTTP. Before I deploy LiteLLM, let's make sure that my inference pods are up and running. So here is my OpenShift cluster, and I have my inference pods deployed in the Poolside namespace. And there is my inference pod. I think I have the route for my inference endpoint. And that is my service corresponding to my inference endpoint. Okay, so to deploy this, I am roughly following the docs from LiteLLM. The first demo we'll be using Docker. So I already downloaded the Docker compose.yaml to my laptop. And it is here. I gave it a master key and a dummy salt. And the deployment itself is pretty simple. You just do docker compose up from the directory where you have the Docker compose YAML. It's coming up. Okay, so it finished coming up, and at the end of it, it exposes port 4000. So I can go to my browser and go to that will take me to the API endpoint, and what we want is the /UI endpoint. And we log in using our admin credentials and the master key, which is demo 123. Okay, here is the landing page. And what we are going to do is we are going to add a model. So in this demo, we are going to be connecting to the, so this LiteLLM instance is running on my laptop locally, and we are going to connect to the inference endpoint that we have on my OpenShift cluster. So you go to Models plus Endpoints tab on the left. You click Add Model. You select OpenAI as the provider. And you want to give custom model name. And then click Outside. And then here, we need the model name with the prefix OpenAI /. So in my case, my model name is Laguna S. And public model name can be anything. We can give it LiteLLM demo 1. And I need my API, which is my route to my OpenShift for my LiteLLM, for my inference endpoint. And I need a key. This key can be anything. I just give it demo. At this point, I can click Test Connect. And then that looks good. We can add the model. Okay, awesome. And it should show up in my all models. And LiteLLM has this playground that I can go select the model that I just added and give it a prompt. It will give me a reply that confirms that I can talk to my inference endpoint. We can use our pool harness to do the test as well. You download the harness from GitHub. github.com/poolside.ai/pool. Then you do pool login, and then you connect to an OpenAI endpoint. Place it is /1000. And I'm logging in using the API key, which is the master key. And then I can type pool, and it will connect me. Okay, it needs. Okay, I ran into an error with pool login when I selected and gave it the API URL as localhost :4000. It couldn't connect to it. So the workaround is to set these 3 environment variables. And then when we do pool, we can get replies from the inference endpoint. And if we go to the logs, we can see all my attempts to log in. And the last attempt would show my input and what is the output it got. Okay, now let's tear it down. And then focus on the second part of the demo. This demo uses the production deployment instructions using Helm. And we don't have OpenShift here, so I had to modify the values.yaml that we need to deploy the Helm chart a little bit. And we can take a look at what we need to do there. Okay. So here we are going to deploy LiteLLM inside the Kubernetes cluster where my inference endpoint is running. And we're going to use Helm to do that. And to deploy, we need to prepare this values.yaml. And let's see what I have in there so far. So I need two secrets, one for the master key, and this is used to log into the UI. It's also used as the API bearer token. I need another secret for the LiteLLM salt key, which is used to encrypt the model credentials stored in Postgres. And let's create a namespace. Okay, I already did create that. Okay. Okay, I already created the namespace before this demo. So let's go ahead and create the secrets that we need. See, it looks like I already created the secrets as well. Okay. Let me make sure that I don't have any Helm installations there. Okay. So as part of this demo, I already created the namespace and the secrets that I need. The document says to deploy a secret for database, but we are going to use the database that is bundled with this Helm chart and not deploy an existing, not point it to an existing database. I'm leaving the proxy config dot models underscore list empty. If I give value, if I give a list in there, then that will render as a config map and it will end up as a static config. What that means is I would not be able to edit the models from UI. So I'm going to leave that empty. I also am setting store model underscore in DB to true so that I can edit and add models from the UI and I can have it persist in the database. This is an optional field to see the logs from the LiteLLM UI. You can tweak this from the UI as well. Since my environment is an OpenShift environment, I'm not enabling the ingress. Instead, I am creating a OpenShift route with my LiteLLM URL, and I already have a DNS for this. And since I'm not using HTTPS, I'm going to use the edge termination policy to allow. I didn't have to make a lot of changes to the existing Postgres other than to move the image to a valid image. I think the one that shipped with the chart did not exist. There are a few other OpenShift related changes that I had to make, like pod security context, container security context. I have a dynamic storage provisioner here, so I don't need to give a storage class. It'll pick the default storage class I have. And since I'm only using one replica, I'm not enabling Redis. The installation is fairly simple. You can use the chart and feed it this values.yaml. Okay, it shows us deployed. Let's check the status of the pods. Okay, So LiteLLM pod is coming up, the Postgres is coming up, and there is this migrations job. We want it to be in a completed state. Okay, setup complete. That would mean that it should, okay. At this point, I should be able to access this from the browser, but we can also use curl to query the LiteLLM endpoint with the master key as the auth token. And I already have a model in there. So the reason I have a model showing up in there is from my last test. When I uninstalled it, I did not clear the persistent volume claim. So whatever I added in my last test still persisted because I have the PVC for the Postgres. But this curl command shows that I can reach the LiteLLM endpoint. So let's go to that endpoint in the browser. And you can see that I already have the model. And since I didn't make it a static model, I can delete this. Okay, now I can follow the same steps to create a model. Give it custom model name. OpenAI. And the API base URL is going to be different from the last time. We will be used, since my LiteLLM instance is running in the same Kubernetes cluster as my OpenShift, as my inference pod or inference containers, I can give it the service URL, which would be the service name dot the namespace dot svc dot cluster dot local. And I can give it an API key. Any non-empty value would be okay here. So if I do test connect, it said connection error. Let's click show details. Okay, it is giving me a get ADDR error. Let's check that. Let me go to my cluster and check my service. Okay, the service name is Laguna S and I gave it Laguna XS. Let's update that to Laguna S and try connect again. Okay, connection is successful this time. Let's add the model. The model is added successfully. Let's run a quick test. Okay, inference did work, so got a reply. We can check the same thing using Pool. That's our harness. Okay, same steps as the last time. We are going to set these 3 environment variables. In this case, we are going to use the LiteLLM endpoint as the base URL. Previously, we used the localhost as the Docker swarm was running on my laptop. And we can connect using Pool. And if I go to my logs, I can see the test query that I gave and the output. So that is a short demo on how to install and test LiteLLM really quick with Poolside. Thank you for watching.